And it's time for the next presentation. It's a utility and confidentiality assessment of synthetic financial data. That's amazing. And the speaker would be Eugenia Koblents. She's a data science expert at Banco de España. She has got a PhD in computational statistics, University Carlos III de Madrid in 2015. She has a master in multimedia and communications, also University Carlos III. She's telecommunication engineering and was formerly researcher in an assistant lecturer in the University Carlos III de Madrid. So also she was a senior machine learning scientist in several companies. So Eugenia, the floor is yours.
Thank you for the introduction and thank you for having me here today. So I will be talking about utility and confidentiality assessment of synthetic financial data. So in particular, I will present the results of a synthetic data pilot in which Banco de España collaborated with the European Commission. Okay, yes. So first I'm going to make a quick introduction to the topic, then I'm going to talk about utility assessment and privacy assessment. So just to briefly introduce the synthetic data pilot, it was launched by the European Commission in summer 2022 in order to support the creation of the EU Digital Finance Platform Data Hub. So basically the goal of the Data Hub was to provide to participant fintech companies with access to non-public data for them to allow to improve their solutions. However, the problem is that often the data that they request is often highly confidential and cannot be shared with third parties. So the synthetic data approach seemed like a very good alternative solution in order to allow sharing of sensitive information without compromising privacy. So the goal of the pilot, our part, was to assess the accuracy and privacy of synthetic data in order to determine whether it's suitable for different tasks such as research or statistical analysis or IT testing. So different partners collaborated in the pilot. It was the European Commission as the pilot leader and coordinator and as the contracting authority. Then there was an AI company which is specialized in synthetic data generation, which also provided training to us. And Banco de España provided the infrastructure and also the data that was used in the pilot. And we also performed the synthetic data assessment. So in Banco de España, there were several departments working on the pilot. It was IT department was building the infrastructure, and also the legal department making sure that everything was compliant with regulations, and the financial innovation department leading the pilot, and also statistics department providing the data and performing the assessment. So just a quick introduction to synthetic data generation. So the idea is to protect sensitive data from disclosure. So there are many traditional techniques based on anonymization or perturbation of the data, which have been used over the last decades, but currently, these methods are not enough anymore to protect ever-growing datasets and more complex datasets. So a promising alternative was to generate synthetic data and sharing synthetic versions of this data with the participants in the pilot instead of sharing the real data. So basically, the idea is to train a model using the real data and then generate new samples from the trained model in a way in which in the synthetic data set there are no real samples, so the risk of re-identification is zero theoretically. And based on the idea that the quality of the synthetic data will be good, that it replicates the real data very well. Okay, so but as we will see later on, the quality of the synthetic data actually depends on the model that has been trained, and we have to actually assess the utility of this data for specific use cases. So we can synthesize the full data set, and then we call it full synthesis, or we can synthesize only some records or some variables, and then we call it partial synthesis. In this pilot, we worked with full synthesis of data sets. So generative adversarial networks is one of the most promising technologies in order to generate synthetic data, which basically consists of two networks, a generator and a discriminator, in which the generator generates synthetic data, trying to fool the discriminator, and the discriminator tries to distinguish between real and fake data until convergence, basically. So I added here some references in case you're interested. So the data that we used in the pilot are two data sets that are currently available to external researchers in the BLab data laboratory. So in this link, you have more information on BLab. So we used these two data sets. CBI contains economic and financial variables built from the annual accounts reported by Spanish non-financial firms. In this data set, we have roughly 1 million samples per year. We have, I think it's 25 or 30 years of data. And for this pilot, we selected only 5 years and 70 variables. And on the other hand, we have the loans to legal persons dataset, which we call CIR dataset, which contains information on loans to legal entities. In this case, we have 5 million samples per year. We have now it's 20 variables. And we have, for each debtor, we have multiple time series, and we also have loans which have multiple debtors, which are called joint loans. So this is just a quick summary of the synthesization exercise that we performed. The software tool that was provided by the AI company participating in the pilot implements the full pipeline of synthetic data generation. So you can upload the data, you can select the training parameters, you can supervise the whole execution, and then you can analyze the results. And the tool incorporates a web-based user interface in order to basically to interact with the tool. And based on the utility and privacy metrics computed by this software, the two data sets have been successfully synthesized both independently and jointly. So here there is a summary of the two data sets. So we have we have here the number of variables, the number of samples, and here that you can see that the accuracy of the synthetic data set, the accuracy computed by the software is very high, is around 98% for all of the different data sets, and all of the privacy tests have been passed in this analysis. So Banco de España, we were curious to see whether this data actually was suitable for the type of analysis that needs to be performed in Banco de España. So we applied some additional tests to make sure that the quality of the data was good enough. So now I'm going to talk a little bit about utility assessment. So utility assessment of synthetic data is a very challenging problem. And it needs to be performed for every data set and for every use case. It needs to be evaluated independently. So some of the main utility metrics that have been proposed in the literature for fully synthetic data can be divided into 3 big groups, which are global metrics, outcome-specific metrics, and fit-for-purpose metrics. Global utility metrics basically compute a number which compares the original data and the synthetic data, and they make no assumption on the type of analysis that will be conducted. So this utility metric is very limited because it's computed on a very aggregated level, and you can't really generalize the results that you get with global utility metrics to a specific analysis. Then on the other end of the spectrum, basically, we have the outcome-specific utility metrics, which measure the utility of the data for a specific task. So, for example, we can compute regression coefficients for original data and for synthetic data, and we can compare them using confidence interval overlap and see whether they are good enough. And then we have something in between, which is fit-for-purpose measures, which provide like an overview of the quality of the synthetic data. So we can, it's very common to use graphical visualization of the marginal and bivariate distributions to check the correlation, to make some consistency checks, and so on. So, well, it's clear from all the literature that it's necessary to perform a detailed analysis, checking different types of utility metrics in order to really understand what's the utility for a specific use case. So these are some of the utility metrics computed by the synthetic data software that we used. So here we can see the software checks the univariate distribution, bivariate distributions, the correlations, and the pairwise accuracy matrix. And the results that we got for all of the different data sets were very good. So we had an accuracy of 97%, The univariate and bivariate distributions looked very good. The correlations looked very, very good also. And as I said, we wanted to make some additional analysis to see whether the synthetic data was actually suitable for the type of work that is done in Banco de España. So two main aspects when trying to assess the utility of the CBI dataset is whether the statistical distributions of the data, of the synthetic data, actually fit the original distributions. And then it's also very important to check that the arithmetic relationships among balanced variables are actually satisfied in the synthetic data. So for this reason, we designed a set of tests to be applied to the synthetic data. On one hand, we had tests on aggregated data in which we checked some global aggregates which we compute for BILAB dashboards, some other summary statistics, and also we checked aggregated variation rates. And then on the other hand, we also made some tests on the microdata to see whether the linear and non-linear relationships which are present in the real data are actually preserved in the synthetic data. So here you can see the dashboards that we created for the CBI dataset. In the upper row, you have the original dashboard. So we have, on the left, we have the number of firms for different categories per region, per sector, per size, and so on. Then in the middle, we have the number of employees, also for the same categories. And then finally, we have the sales on the right. And on the lower row shows the dashboards that we obtained with the synthetic data. So we can see that the number of companies per sector, per region, and so on is very well modeled in the synthetic data. But you can also see in red squares the difference that we can see in the number of employees and the sales of the company per company size or per region or per sector. There are some significant differences. So for example, we can see that the regional distribution is slightly smoothed in the synthetic data, so we don't have such a strong dominance of Madrid with respect to other regions. And also the number of employees and the sales per company size is also different, because in the real data, large companies have a very big contribution to the number of employees and to sales, and in the synthetic data, it's not the contribution is not as large. So when we discussed these findings with the software provider, they mentioned that there is some outlier suppression step prior to synthesizing data, which was actually causing this type of effects in which they were suppressing the outliers, basically. So they were suppressing the largest samples. Usually they are located in Madrid and they usually correspond to the largest companies. So this is the reason why these statistics are more affected than other statistics. So in order to understand this a little bit better, we also checked some other statistics apart from the number of companies and the total amounts. Here you can see for the sales per company size, here we checked the mean and the standard deviation, the maximum, the median. And what we saw was, again, that the count is very well reproduced. So we have the same number of companies per company size in the original dataset and the synthetic dataset, but the total amounts, the mean, the standard deviation, and the maximum are actually heavily affected by the synthesization, because the outliers are previously suppressed. And other experiments that we did was to check whether the balance variables that we have in the real dataset are actually still balanced in the synthetic dataset. So we selected a number of equations which hold in the real dataset, such as this one, for example, the total assets is equal to non-current assets plus the current assets. So this relationship strictly holds in the original dataset. But if we check the deviation of the first term and the two summing terms, basically, we see that in the synthetic data there are really big deviations between the total assets and the sum of current assets plus non-current assets. So we did a similar comparison for 5 different equations, and you can see that there are very large deviations. In the original data, we had around 0.2% deviations, and in the synthetic data, we often have deviations above 40%. Okay, so this was the bad news, actually, when analyzing this, the utility of this data. When we found this, actually, it was a very negative finding actually. So we also discussed these findings with the company providing the software, and they suggested to discard samples which are unbalanced. But this was actually not an option because the percentage of discarded samples would be close to 100%. And another suggestion they made was to provide them with the set of all of the linear equations which are satisfied in the real data so that they could be enforced in the synthetic data. But this was also not an option because there is a very large number of these equations. So basically the feedback they gave us is that they would work on that. So hopefully it will in the near future, hopefully it will improve. So now I'm going to talk a little bit about privacy assessment. So when generating fully synthetic data, as I said, there is no link between real samples and synthetic samples. So the risk of re-identification doesn't make much sense assessing this risk because there are no synthetic samples don't have any connection to real samples. But in national statistics authorities always usually are concerned about the reputational risk that can occur when there is some sample in the synthetic data set which is equal or very similar to a real sample, because respondents might be concerned about this fact. So if you have some characteristics which are very unique and you find exactly the same characteristics in the synthetic data sets, well, the respondents might be concerned about that. So when this type of unique matches occur, they are usually suppressed. Also, there are other sources of risk which can come from membership attacks or inferential attacks, which can also sometimes also need to be assessed. And one common way of assessing the risk for synthetic data is to measure the distance between synthetic and real samples and to identify this set of unique matches, which are usually suppressed. But this is still also an open research topic, and it needs more research to be actually standardized. What are the metrics to be used to assess privacy in this type of data sets? So these are the metrics that the company providing the software computed. So on one hand, all these metrics are based on a distance computed between real and synthetic samples. So we have the identical match share, which gives you the percentage of samples which are the same in the real and the synthetic data set. Then we have the distance to closest records and the nearest neighbors distance metric. So basically the idea is to compute these metrics for the original data set and for comparing the original and the synthetic data set to see if there are more similarities between synthetic and real data than in the real data itself. So all of these tests have been passed according to the software. So the software didn't see any issues with privacy with the synthetic data sets. Well, we have some concerns here because it's not clear how the software actually computes the distance between real and synthetic data, because I will show you now what's the problem with computing distances here. So we did this exercise of checking whether there are unique matches between real and synthetic data. So we had to compute the distance basically between all of the different debtors. But the problem is that the data that we have for each debtor looks like this. So we have a variable number of loans, which each of the loans has a time series. And then we also have some attributes which are different from the different time series. And each time series actually occurs in different time instants. So it's not a standard data for which you can compute distance easily. So what we did was to summarize all of the debtors' information into a debtors profile. So here we kept in the profile the static information of each debtor, which is the country, the sector, the size, and all these 5 variables. And then we add kind of a summary of the time series data. So we have a number of variables for the order of magnitude of the loans, then for the currencies of the loans, the region of investment, and the guarantees. And we code it in this way. So if a company has invested in Madrid and Galicia, for example, we will have 1 and 1 there. And if they have loans of 1 to 7 digits or loans of 1 to 6 or 7 digits, then we will code it in this way. So this debtors profile here, it has a fixed dimension, so it's easy to compare those. So what we did was to generate this fixed size profiles for each of the synthetic debtors and also for each of the real debtors. And then we have extracted the unique synthetic profiles and the unique real profiles, and then we have compared those. So in the first round, we found 700 profiles which are unique among real data and synthetic data. And then also checking the number of loans, we had only 83 replicated profiles. And then finally, we identified 5 suspected replicated uniques, which have very, very similar profiles. So here you can see an example. So here we have the profile of a real sample and the profile of a synthetic sample. So here you can see that they are almost the same. It's only the only difference is that the real sector is unknown in the original data set, and in the synthetic data set there is a value for the sector. And then the numerical data is exactly the same, so we have the same time series. In this case, the time series is there is only one loan and it only has one sample, so it's a very low dimensional case. So as the dimension of the time series grows, actually the probability of having unique matches decreases exponentially. So we don't really think that there is any risk associated to this, but for it's standard practice to simply suppress these samples to minimize reputational risk. Okay, so just a quick summary. So Banco de España recently participated in the synthetic data pilot, in which the goal was to evaluate the quality and the confidentiality of synthetic data. So the main outcomes are that we didn't find any issues with the privacy of the synthetic data, but we did find some issues regarding the utility of the synthetic data, because we found out that summary statistics are very affected by outlier suppression. We have the intuition that if we only worked with SMEs and only variables describing ratio instead of absolute values, that we would have better results. We also found out that the linear and nonlinear relationship among balanced variables are not always preserved in the synthetic data set, so this is the main limitation that we found. Another limitation is the fact that it's not possible to merge synthetic data sets that have been synthesized independently. So this is basically the conclusion. Thank you very much for your attention.
Well, thank you very much, Eugenia. Eugenia is a member also of our team, and I know her very well. And when I read that you will present this in this session with ESG data, well, I said, what the hell connection we have on that? So let me give a context to all the members, and afterwards a question for you. The context is that, we know that we are trying to get information, for example, about the gas emission scope 1, and we want to obtain from a Spanish company that is Endesa. Endesa is an energy supplier. The bad luck is that this information perhaps will be not available because Endesa is a part of a multinational group that is Enel, that is an Italian group. So if we are not lucky, in the future we will have the information of what happened with Enel, that is the Italian group, but not what is happening in Spain with Endesa, that is the Spanish company. This is what is happening in Europe. I don't know if in the rest of the world would happen the same, but ESG, we are talking about information, how difficult it is to get this information, and on top of that, the problem is that the information is on the group. So if we want to obtain information from Spain, we have also to look for other places where this information is. Borja and the team of Nati, they have been working with other institutions to look for information in other administrative sources, because the information about the gas emission, that is something that would be available in the non-financial data, is also available since 20 years ago, 15 years ago, in some administrative sources that currently exist in all Europe, not only in Spain. That is the administrative sources of pollutants. That is something that is available not company by company, is available plant by plant. So in Europe, we know each plant in Europe, what is the emission that you have. And this information is available in some ministers in Spain, and they have the information with an identifier that has to be crossed with other identifiers. And this comes the problem is some of these data are confidential. You can't share this information because the information exists, but the information is confidential. So perhaps the law changes, but if not change, why not try to use synthetic data to say, well, we have the data we can merge and share and put all together, and with the synthesization, it seems that perhaps afterwards we could manage to use this data. And here is the question. From our experience this year, we will be lucky or not. The results will be good, or we should think that the synthesization will not work in this environment.
Well, I think nowadays the technology is maybe not quite mature, but I'm really confident that probably in a few months maybe we can be there, because as we see the huge advances that are made in the field, I think really that we shouldn't. I'm very optimistic about this, actually. I think nowadays still it's you have to be careful with drawing any conclusions based on synthetic data, but I would still be. I think we have to pay attention to these technologies. Yes. Thank you.
Hi, thank you for your presentation.
Thank you.
So when we, I'm from Deloitte, and we have also a group looking at synthetic data. Another approach that they sometimes take is looking at something called secure multi-party computation. Have you been examining that?
Well, I have read some literature, yes, but from what I've read, it's really a very computationally heavy strategy. So it's really has to be a very limited problem that you want to solve. So I read that the complexity of that is around 10,000 times the complexity of doing it distributedly. So we are not considering this technology yet because it's really too costly.
Yeah, sure. And that has also been the case. There is a company called Nelion that has actually kind of cracked that nut in terms of competition heavy. So if you are doing more pilots and want to explore the other paradigm, Nelion is definitely a company that is worth.
What's the name?
Nelion. N-I-L-E-O-N. And because instead of creating synthetic data, you have this masked model where you mask the data, and then you can also compute directly on the masked data without revealing true or synthetic data. But,
Yes, and this pilot in which we participated actually. Right now, the European Commission has already decided this pilot was to assess a little bit the technology, and the next task was to select a company which would do the task of synthesization. So right now, actually, there is already a company selected. So we still don't know what company is that. But now the European Commission will start working heavily on that. So Banco de España is within the team of banks who will. Possibly contribute data, so we have to see what's the result of this analysis. But yes, I think it's a hot topic actually. So,
right, thank you.
Thank you.
Two more questions.
Thank you. Yeah, first of all, thanks very much for this wonderful presentation. It's very interesting for us. I really like the idea of analyzing the synthetic data for example, data leakage or data duplicates. And since we are speaking about maybe some ideas or maybe some recommendations, which I really appreciated from you guys, one thing that I want to maybe also make you aware of is actually we are working in a collaboration with the German Central Bank or the Deutsche Bundesbank on a project where this is also the idea, and I mean, we started a couple of years ago and evaluated generative adversarial networks, which obviously, as you said, or investigated, didn't work properly, but maybe one idea that you might be interested in or want to have a look into is maybe stable diffusional models, which are more the latest or a later trend in generative modeling. So that's probably something. And if you don't mind, maybe I would like you to connect you with the colleagues over there, because they are generating already some data, and maybe it would be cool to collaborate and so that you can test maybe what they generate and see. Thank you so much.
Thank you so much for the comment.
All of you who are asking questions seems to be in this space where you seem to know why you're doing it, but I'm still a little lost as to why you need synthetic data at all. You have regulators, you have access to data, and I mean, I just don't understand. I mean, if you're trying to maintain the relationships, then presumably the relationships are really what's sensitive, right? So what is the underlying basis for what you're doing?
Well, the idea of this pilot specifically was to help create the data hub for the European Commission. So the idea there was to make data available to private companies who that make research on the fintech area and the fintech. So in order to provide to them this data, which is sensitive, so that they can better implement their solutions. But as this data is very difficult for Banco de España, for example, cannot share the data that we have for the loans data, for example, cannot be shared. So this was just like an option of, okay, we are not going to share the original data, but we can share the synthetic version of the data. So under the... Sorry?
Is this like a resource to create artificial intelligence or something? I mean, I'm just trying to understand what the purpose is of
well, the purpose. Yes, the purpose is to be able to share data that you cannot share due to legal restrictions. So you might have some data that is very interesting to the public, but you cannot share it because it's very, very sensitive. So you can't re-identify individual samples from this data. So the point is, okay, I will generate a synthetic population of data that is very similar, which has the same distributions, which have the same relationships, but it's completely fake. So it's just very, very, very similar, but there is no risk for identification there because there are no real individuals there. So that's the idea. Do you want to add some? Yes, that's the.
Yes. Remark from maybe from the Bundesbank or the German central bank. That's exactly the idea. So basically, they want to generate synthetic data. For example, because we all know that these deep learning models, they're very data hungry. To train them, it's very data intensive. And if you want to train a deep learning model, for example, to detect anomalies, maybe in macro data or micro data that the central banks receive, you need to have synthetic data that actually has the same characteristics as the original data.
Yes, also with these models you can generate as much data as you want. So you can train a model and then you can generate one, because for deep learning models, for example, you need huge amounts of data. So you can generate as much as you need. So.
Would you put your slide with the variables, like how many you had? One of your early slides had like how many categorical
yes.
variables you have. Could we have a look at that?
Can we have a look at that? Yes, this was just a subset of the original data sets. So we selected, yes.
Because we, on our outlier detection project I mentioned before, we are using
yes, thank you. So the main bulk of variables was from the CBI dataset, because we had, in the original dataset, there are like 200 variables. So we selected a subset for this to be feasible to run in a limited period of time, because we only had a couple of weeks to run this.
And you've verified the statistical trustability of this. You did verify that this really represents, to a certain degree, the real population, right?
Well, this was just the sample that we have here it was a random sample of the population, so we didn't do much test. We took the original dataset, the CBI dataset. We selected a number of variables that were considered relevant for the synthesis exercise, and we generated the samples of the individuals. Yes.
You know, early on, someone presented about the ethics of data, right, using artificial intelligence. I mean, this is a very dangerous road, right, potentially, because you are creating data, right? Now, you are assuring us that it's the same relationships and so on, right? But of course, you could easily manipulate this to get any training you like into these super AI data sets, right?
That's what I was asking.
Yeah, because this is not anonymous data.
From a real data set.
Yeah, no, but this is not anonymizing data. You're taking that data and then you can increase it as many times as you like.
Yes,
and you are claiming that the relationship's identical and so on, right?
Yes,
but again, it comes back to what the original point is, right? I mean, what are you trying to hide? Okay, if you're trying to hide the name, you could multiply by a random number, right? I mean, that will give you the same effect. But you are going beyond that. You are manufacturing data, supposedly maintaining the same relationships. Now, it's the relationships that are actually what's valuable, right? It's not the raw data. It's the fact that one variable is linked to another and so on, right? So, you know, the question then is, what is the ethics of doing that? And why would you do that in the first place, right? I mean, you're a regulator, right? I mean, you have access to the data anyway. You don't need to anonymize it. But you are generating data for a third party, supposedly for their benefit, right? Well, you can, of course, manipulate that. I mean, the Chinese government, I can imagine, would create synthetic data that is going to be very different.
Yes, that's why
right?
utility is so important.
Yes,
so you can't just generate the synthetic data and circulate it and allow the people to do whatever. So.
One final question. I think we have. This is time for lunch.
Perhaps abusing that we are a part of the organizers. Let me tell you some kind of joke that happened last year that shows you why we are so different, and at the same time we work with the same things. But we have to prepare a non-paper. It's called in the G20. That this was something prepared Europe, China, and the United States. We prepared the first part of the document in Europe, and the paper was data setting guided by principles. The idea was to prepare a paper saying, how could we make data setting B2G, business to government? And well, the Europeans, all our need was about anonymization. What happened with anonymization and confidentiality and all this. When we prepared the paper, we passed to the Chinese delegation, and the Chinese delegation said, why the hell you are occupied on this anonymization? No, all the information is from the government. We have all the information. And when the American delegation came, said, why you are so occupied on this? Pay for the information and you get the information. So, and all the three were true. For this reason, perhaps we need in Europe the synthetization of data, because well, some data are currently very confidential, although a part of this information, if you go to Google, you find there. But well, from the administrative sources, they don't want to provide the information. For that reason, we need the synthetization. So, Enrique, thank you for
Thank you for your explanation.